Hi, my name is Dave Betcher. I'm the Director of Field Operations with Next Step Living. We're an energy audit firm based in Boston, Massachusetts. And at Next Step Living, we try to build relationships with community groups, municipalities, cities, employers, in order to really get a larger number of people involved in improving the performance, the comfort, and the health and safety of their homes. By partnering with larger entities like the City of Boston, we're able to really make a much deeper impact in not only in the city as a whole, but also individuals' homes. We're here today at a home in West Roxbury, where we're doing our typical 3-hour audit with all the industry-leading technology like infrared cameras, the blower door, as you see set up in the door there, which is a fan that depressurizes the house, that emphasizes air leakage, which allows us to really pinpoint the leakage in the home and make more of an impact today.
Next Step Living is providing their service free of charge to homeowners and renters in Boston whose household income falls between 60 and 120% of the median. These are residents, often the working poor, who are not eligible for low-income weatherization assistance programming, but can rarely afford the investment in efficiency that will permanently lower their utility bills.
We always start our visits down in the basement with our combustion safety analyzer, which is basically a really fancy carbon monoxide detector. And we want to make sure that the system, your heating system, both the furnace or the boiler and the hot water system tank, are not producing any excess carbon monoxide, either in the ambient air or in the heating fluid itself. Because as we tighten up the home, the key to an energy efficient home is a tight home. And as we start to tighten that home up, we want to make sure that there's no dangerous gases that we're trapping inside. So with this device here, we'll measure the we'll measure the carbon monoxide levels within the flue itself. And after we get a reading on that, we'll also measure the carbon monoxide levels just in the ambient air to ensure that there's no dangerous levels, which there's not. So we can proceed with all of our weatherization measures here today. So as part of the visit here today, we've also wrapped the pipes on the hot water tank, both the hot and the cold side, because warm water actually migrates up the cold side as well. And so wrapping the first 3 or 4 feet of each side is really a no-brainer move. It will save you $20, $30, $40 a year or something like that, and it only costs $5 for the material. So the payback is pretty immediate. Some of the real easy, low-hanging fruit are things like shower heads, aerators, pipe wrap, and energy-efficient compact fluorescent light bulbs. This aerator right here is 2 gallons per minute, and it has this nice flip function so that when you get the water up to temperature, you can flip it off, and it reduces the airflow. Reduces the water flow. It replaced this one, which was doing 0. It had no restrictor in it at all. So this was probably more like 4 gallons a minute. So right here we've not only saved water, which is great for the environment, but also reduced the amount of hot water that is used and saves you on your utility bill because you're not having to pay to heat up that water. Also, if we notice here, this board up here is quite loose, and it's open on the back side to the wall cavity. So there's going to be a tremendous amount of air movement coming up from behind this this piece of trim here. And so we'll get some white caulking, and we'll fill in the gaps around the window here, around the window over here as well, which will tighten up this area of the home.
Next Step Living is committed to hiring weatherization professionals from within the communities they serve. Boston Connects, a housing and urban development funded organization, is supporting that goal by finding qualified candidates and providing funding to hire and train up to 8 residents from Boston's Empowerment Zone. The Boston Connects funds are reinvested into the community by providing Next Step Living's service to additional homes.
Another very simple switch out are energy efficient lighting called compact fluorescent light bulbs. And these days the technology has improved pretty significantly, and they're basically instant on. And so that old flickering and warm-up period is no longer really a concern. So they just replace a traditional incandescent light bulb. The benefits of an energy-efficient light bulb are they use about 75% less electricity. So every light that you have on for 3 hours a day over the course of a year, you'll save $10 per light bulb. So if this room was used for 3 hours a day, just by switching out these light bulbs here, they'd save around $40. And as you can see, they're basically instant on. They do have a tiny warm-up period, but not like the old days, and they really provide pretty sufficient light. And it's just a easy, simple, no-brainer move. You should replace every commonly used light in your house with an energy-efficient bulb. So in here we notice that there's a lot of wires. Obviously this is the electrical panel. A lot of wires that run to the outside, right through the sill plate. And so you can see that the fiberglass is all dirty, indicating that there's just constant air movement across the fiberglass. So with this nice long-barreled gun here, you can just get up in there and spray a bunch of foam all around the gaps to seal it up nice and tight. So stopping air movement at the basement is one of the keys to an energy efficient home, because all the air that comes in the basement then makes its way up the house and out the attic, which is called the stack effect. So the key is to tighten up the basement and tighten up the attic, and then worry about all the interior stuff last. It's a little bit counterintuitive, but that's how air movement in a house works.
Next Step Living service combines the knowledge of experienced field staff with the analytical capabilities of targeted retrofit energy analysis tool software to provide homeowners with a data-driven whole house energy analysis. This energy analysis software is widely accepted by local, state, and federal governments, as well as by utilities, as a trusted home analysis tool, and has been approved by the U.S. Department of Energy for use in weatherization assistance programs.
So Steve's here working on our energy model. In order to get accurate savings numbers for our recommendations, we need to create an energy model for the home. We basically create an energy model for what the home looked like when we arrived, and then we can change the insulation in the walls, add insulation to the attic, replace the boiler, replace windows, whatever it happens to be. We can then model that and get predicted savings based on the temperature that the homeowner keeps it, if they have a programmable thermostat or not, the efficiency of their boiler, the cost of gas or oil or electricity, whichever way they heat. And you wrap that all together and you can get a fairly accurate prediction based on savings for insulating the walls. Maybe it's $300, $400, $500 a year or something like that, at a cost of $2,000 a year. You throw in some utility rebates, and it's less than a year payback. So one of the tools that we use in the home to pinpoint air leakage, determine if the walls are insulated or not, and really find the issue spots in the home is an infrared camera. And so this, we know that the window is going to be colder than the wall, but you can see pretty clearly that the window right there, the darker colors are colder, and the warmer colors, here's a heating pipe within the wall. So we know that the window is cold and that the heating pipe is warm, but this is what you can do. You can use the camera to determine if walls are insulated or uninsulated, and maybe behind a bathtub if there's no insulation. And in conjunction, we also have a fiber optic probe that we can stick into the wall and actually look in there with a camera and determine if there's insulation in there or not, which is a pretty cool tool. Another great piece of technology is what's called a blower door. It's pretty well named. It's a big fan that goes in the door that depressurizes the house, so it draws air from inside the house and blows it out. And in doing that, it draws in exterior air through all the small gaps in the attic, in the basement, in the walls, around windows and doors. And with the blower door running in conjunction with the infrared camera, you can really pinpoint the leakage quite well. The blower door is a great it's a great diagnostic tool as well, because you can get a baseline number before we show up, then we can run around caulking windows, air sealing in the basement, air sealing in the attic, and we can turn the blower door back on, and we can actually quantify the reduction in air leakage that we've been able to achieve based on the before and after numbers with the blower door. This is the manometer that it's just a small computer that reads how hard the fan is working and different pressures, which is how you get the blower door readings.